Hi, this is Professor Stugard, and in this video we're going to learn a little bit about how to do mathematics with matrices in Python. Alright, so I have opened a new Jupyter notebook with Python. I can even rename this Matrix Math, rename it. Now, to be able to create matrices and to do matrix math, we do need the package NumPy, so I need to import NumPy. And again, I'm going to do this as NP so that I can use those abbreviations effectively. Shift Enter, good, no error messages, so that must have worked correctly. So what I want to do is create a matrix, which is really an array of values, and basically array is the function we're going to use. So I'm going to do capital A, because again, we typically name our matrices with capital letters, and my function comes from the NumPy package, so np.array, and we'll do parentheses, because again, that's my function. And now to actually create my matrix, I'm going to need to use square brackets. So I need a first set of square brackets to denote the entire matrix itself. And then I'm going to separate each row with another set of square brackets. So I need those two sets. So let's say for A, it's 1, 2. So we'll just do a quick 2 by 2. So my first row is going to be 1, 2, comma, and then I need another set of brackets, and then 3, 4. That'll create my array A. If I want to view it, again, I'm going to have to add that line that I actually want to see what I made. So if I hit Shift Enter, now I see that good. My variable A is stored as an array where I have 1, 2, 3, 4 as my entries. So again, when you input an array, whether you're using values from a list that you already have, the default is that it's going to create your array based on the rows. So each observation becomes its own entry into your matrix. All right, so let's create another one. Let's do matrix B and p dot array. Again, parentheses, square brackets for the entire thing, and then square brackets for each of the rows. So let's pick some random numbers. So maybe -2, 5, comma, how about 4, oops, another set of square brackets, 4, 7. And then again, we'll make this a with 3 rows and 2 columns, so a 3 by 2. All right, and so let's see. Then my last one, I'll do how about 0, comma, -3. Enter B because I want to view it to make sure it came out all right. Shift Enter, good. And then I have my 3 by 2 matrix. Now, when I do my matrix mathematics, so let's start with maybe matrix multiplication. So we had to be careful here because, again, remember, matrix multiplication only works if the columns match the row, right? So matrix A is a 2 by 2. Matrix B is a 3 by 2. I need to make sure that when I multiply, the middle numbers are going to match, which means I need to do it as B times A. And I run it. Wait a second. Operands cannot be broadcast together with shapes. Well, yeah, we're doing matrix mathematics. So it's not going to be the time symbol. It's actually the @ symbol to do matrix multiplication. But now I hit Shift Enter, and sure enough, there we go. That is the result of multiplying B times A. Now I had to do that because otherwise the dimensions wouldn't match. If I tried to do A times B the other way, Shift Enter, I'm going to get an error. We have a mismatch in the core dimensions. And again, we have a bunch of other stuff, but basically size 3 is different from 2. A is that 2 by 2. B is a 3 by 2. So the size mismatch 3 is not the same as 2. We can't do that operation. All right, but if I go back, and let's remove one of those rows from B. So I have 2 square matrices. I'll run my code again. Now I have B sorted as a 2 by 2 instead. Again, nothing else is updated yet, but it can update. If I rerun my code, now B times A is this 2 by 2, and then I can now do A times B, which again is going to be a separate 2 by 2 matrix. And I can actually do my matrix multiplication. If I do want to add the matrices together, A plus B, that actually does work. The addition works pretty straightforward. I can also do 3 times matrix A, and that'll work as well. The scalar multiplication is the time symbol. It's the @ symbol for matrix multiplication. Now let's see. I'm going to go back. Here, let's create a third matrix C. So np dot array parentheses bracket bracket. So let's do 0, 1 for my first one, comma. My second row will be about 5, 6, comma, and then my third row 8, 9. And so we'll just double check to make sure that came out all right. Good. So I have my array here. I have my 3 rows and 2 columns, so I have a 3 by 2 matrix. One of the operations we can do on matrices as well is to transpose them. So transpose basically means we flip the rows and the columns. I do this by using the transpose function. So I can do this a couple of different ways. So I can say C dot transpose, and again, what that means is we're going to take our object C, which is our matrix, and we're going to apply the function transpose to it. Shift enter, and now we see that our new matrix is now 2 rows and 3 columns. And so again, all that did is kind of shift that around. So those are the basics for creating matrices and kind of playing around and doing some matrix multiplication, matrix addition, and scalar multiplication, as well as transposing it. There's a lot more that we're going to talk about in terms of matrices and linear algebra. But again, these are just the basics to kind of help you get started and to play around and do some matrix math. So have some fun playing around, and well, take care of yourselves.